Welcome to a lesson on expected value. In this lesson, we will define expected value and also determine the expected value of an event. Expected value is an extremely useful probability concept to learn. It has many applications ranging from insurance policies to making financial decisions. It is also one thing that the casinos and government agencies that run gambling operations and lotteries hope most people won't learn. Expected value is the average gain or loss of an event if the procedure is repeated many times. We can compute the expected value by multiplying each outcome by the probability of that outcome, then adding up the products. So let's take a look at an example. You purchase one raffle ticket for a school fundraiser. The raffle ticket costs $5. The school is selling 10,000 tickets. One ticket will be randomly drawn and the winner will receive $10,000. Assume all tickets are sold, compute the expected value. So again, the expected value would be the expected outcome if you played this lottery over and over and over again. So the first thing we need to recognize is that there are 10,000 tickets and you only purchase one, therefore the probability of winning is 1/10,000th, which means the probability of losing would be 1 minus the probability of winning, or 9,999 divided by 10,000. Next, if you win, you don't really win $10,000. You'd actually have to subtract the cost of the ticket. So if you win, you actually win $9,995. And of course, if you lose, then you lose your $5 from purchasing the ticket. This is the information we need to find the expected value for this event. The expected value is going to be equal to the outcome of winning times the probability of winning plus the outcome of losing times the probability of losing. So again, if we win $9,995. The probability of this occurring is 1/10,000th. If we lose $5. The probability of this occurring is this probability here. So we find this product, and then find the sum to find the expected value. So $9,995 times 1/10,000th is equal to $0.9995, and then -5 times this probability is equal to -4.9995. Find the sum here. The result is -4 or -$4. This is our expected value for this event, which means if you were to play this lottery time after time after time, the expected result would be that you would lose $4 each time. Let's take a look at a second example. A company estimates that 0.2% of their products will fail after the original warranty period, but within 2 years of the purchase with a replacement cost of $250. If they offer a 2-year extended warranty for $28, what is the company's expected value of each warranty? So we're thinking of this as if we are the company, which means the probability of having to replace the product would be 0.2%, or as a decimal, 0.002, which means the probability of not having to replace the product would be 1 minus 0.002, or 0.998, or 99.8%. Next, the cost of replacement under warranty would not be $250, it would be the cost of the warranty minus the replacement cost. So notice how the true replacement cost for the company is $222. And again, this is negative because it's costing the company money. If they're gaining money, it would be positive, which means the revenue from non-replacement would be the $28 charged for each warranty. So one thing we do have to be careful about here is watching the signs when we're gathering this information. But this is the information we need in order to find the expected value for the company. The expected value is going to be equal to the replacement cost of -$222 times the probability of replacing the item, which as a decimal is 0.002, plus the extra revenue from not having to replace the item, which is $28, the cost of the warranty, times the probability of not having to replace the product, which as a decimal would be 0.998. So if we find the sum of this product, we have the expected value for the company. So this first product comes out to negative $0.444. The second product comes out to $27.944. Finding the sum here, notice how the result or the expected value is $27. Which means as they sell more and more warranties, the expected value or extra revenue would be $27 per warranty sold. I hope you found this lesson helpful. A bag of marbles contains 2 gold marbles, 10 silver marbles, and 30 black marbles. You decide to play the following game. Randomly select one marble from the bag. If it is gold, you win $5. If it is silver, you win $2. If it is black, you lose $2. What is the expected value if you play the game? The expected value is the average gain or average loss of an event if the procedure is repeated many times. We compute the expected value by multiplying each outcome by the probability of that outcome, then adding the products. So looking back at the given information, notice how the bag contains 2 gold marbles, 10 silver marbles, and 30 black marbles. So the total number of marbles would be 2 plus 10 plus 30, which equals 42. Let's write this down because we need this to find the probability of each outcome. And now there are 3 outcomes. You can win $5 if you select gold, you can win $2 if you select silver, and you can lose $2 if you select black. So the expected value is equal to the outcome of winning $5. You win $5 if you select gold, so we multiply by the probability of selecting gold, and there are 2 gold marbles out of 42, so the probability is 2 42nds, or 2 divided by 42, plus the outcome of winning $2, so plus $2, times the probability of winning $2, which would be the probability of selecting a silver marble. There are 10 silver marbles out of 42, so we have 10 42nds, or 10 divided by 42. Plus the third outcome is that you lose $2, so we'd have plus negative $2, times the probability of losing $2, which is the probability of selecting a black marble. There are 30 black marbles out of 42, so the probability is 30 42nds, or 30 divided by 42. Notice how these probabilities do simplify, but since we're concerned about the sum of these products, we can leave it in this form, and we'll go to the calculator. And because our expected value is in dollars, we'll round to the nearest cent. So we'd have 5 times 2 divided by 42 plus 2 times 10 divided by 42. Then here, because we have plus a negative product, we'll just write minus 2 times 30 divided by 42. Rounding to the nearest cent, we have approximately negative 71 cents, or negative $0.71. So this is our expected value, which means we can expect an average loss of 71 cents if this game is repeated many times. So let's write this out. If the game is repeated many times, the average loss is 71 cents, or $0.71. Notice how we don't include the negative here because we already indicated this is a loss. I hope you found this helpful. The PTO is selling raffle tickets to raise money for classroom supplies. A raffle ticket costs $5. There is one winning ticket out of the 240 tickets sold. The winner gets a prize worth $98. The first question is, what is the expected value to you of one raffle ticket? Let's answer this question on the next slide. To begin, the expected value is the average gain or loss of an event if the event is repeated many times. We compute the expected value by multiplying each outcome by the probability of that outcome, and then we add the products. Let's begin by determining the probability of winning. Because there is one winning ticket out of 240 tickets sold, the probability of winning is 1 divided by 240, and therefore the probability of losing is 1 minus this value, which is 239 divided by 240. There are 239 losing tickets out of 240 total tickets. And now let's determine the gain or loss of winning. If you win a prize worth $98, but you still had to buy the ticket for $5, and therefore if you win, the gain is $98 minus the cost of the ticket, which is $5, and therefore the gain is really $93. And then the loss of losing would be the loss of the price of the ticket, which is $5. To indicate the loss, we use negative $5. And now we have the information we need in order to determine the expected value. Again, the expected value is equal to the sum of the products of the outcomes and the corresponding probabilities. Let's consider the first outcome of winning. Again, if you win, you gain $93. So we have $93, and we multiply by the probability of winning, which is 1 divided by 240, and then plus the second outcome is that you lose. If you lose, you lose $5, so the outcome is negative $5, times the probability of losing, which is 239 divided by 240, and now we determine the sum of the products using the calculator and round to the nearest cent. So we have 93 times 1 divided by 240 plus negative 5 times 239 divided by 240. And enter. To nearest cent, we have negative $4.59. So going back to the first slide, the expected value to you of one raffle ticket is negative $4.59, which means you can expect to lose $4.59 for buying one raffle ticket. Next, we're asked to calculate the expected value to you if you purchase 10 raffle tickets. To calculate this, we multiply the expected value of negative $4.59 by 10. So negative $4.59 times 10 is equal to negative $45.90. So if you buy 10 tickets, you can expect to lose $45.90. The next question is, what is the expected value to the PTO of one raffle ticket? Well, if the expected value to you is negative $4.59, indicating you lose this much per ticket, then the PTO is going to gain this amount per ticket or for one raffle ticket. So the expected value to the PTO is positive $4.59 for one raffle ticket, because they can expect to gain $4.59 by the sale of one raffle ticket or per raffle ticket. And the last question is, if the PTO sells 240 raffle tickets, how much money can they expect to raise for the classroom supplies? Well, that's going to be the expected value of one raffle ticket times 240. So $4.59 times 240, which is $1,101.60. Again, the positive values represent gains, the negative values represent losses. I hope you found this helpful. A 40-year-old man in the U.S. has a 0.244% risk of dying during the next year. An insurance company charges $300 per year for a life insurance policy that pays a $100,000 death benefit. What is the expected value for the person buying the insurance? Round your answer to the nearest dollar. The expected value is the average gain or loss of an event if the procedure was repeated many times. We compute the expected value by multiplying each outcome by the probability of that outcome, then adding up the products. So let's first determine the probability of dying, which is given as 0.244%, which we must express as a decimal. So we have 0.244%, which as a decimal is 0.00244. Next, we need the probability of living, which is going to be 1 minus the probability of dying, which is 1 minus 0.00244, which is equal to 0.99756. Next, we need the gain or loss from death. So if the man dies, he does receive the $100,000 death benefit, but he did pay $300 for it, and therefore the gain from dying, at least the gain to the family, would be $100,000 minus the cost of the policy, which is $300, and therefore the total gain is $99,700. And then the gain or loss from living is that they pay for the policy and don't use it, and therefore there's a loss of $300, which we indicate as negative $300. And now we have the information we need to calculate the expected value. To determine the expected value, we multiply each outcome by the probability of that outcome and then sum the products. So one outcome is the gain of $99,700. The probability of this occurring is the probability of death, which is 0.00244, and then plus the other outcome is a loss of $300 times the probability of losing $300, which is the probability of living, which is 0.99756. And now we need to find the sum of these two products, and we're told to round to the nearest dollar. So going to the calculator, we have 99,700 times 0.00244, and then plus negative 300 times 0.99756, and enter. The expected value is negative $56. This indicates the average loss for all the 40-year-old men buying the policy is going to be a loss of $56. On the opposite side, though, this also indicates that the insurance company will gain an average of $56 each time they sell this life insurance policy to a 40-year-old man. I hope you found this helpful.